Hello, welcome. Thanks for joining us. I hope everyone's having a good time at reInvent this year. My name is Ryan Holland. I'm a principal technical specialist for the external security services team. We're the group that creates and owns GuardDuty and Security Hub. We're going to talk about threat detection and cloud using both of these tools. The agenda for today, we're going to give an overview of GuardDuty, followed by an overview of Security Hub, and then talk about how we can operationalize some of the findings that come out of GuardDuty. Over the last couple of years, I've had a chance to talk with a lot of our customers who have been using GuardDuty and got some insights into some of the common patterns that customers need help with to understand and get the most value out of the findings that GuardDuty is creating for them. And we'll look at three key tenets, right? So first, filtering out and identifying what is noise for you, figuring out what are the high priority findings you want to focus on first, and then lastly, give some examples around how you can automate the response, right? Especially as you start getting really big in scale. Having humans do everything is not going to work at a large scale because there's just not enough humans to respond to all the alerts when you get really, really large. Out of curiosity, how many people are using GuardDuty already today? Oh, that's a pretty good number. What about Security Hub? Oh, great. So while today we're going to talk mostly only about Security Hub and GuardDuty, I do want to point out that these are only two of many of the services that touch on security in AWS. And one of the ways that we like to kind of present these or kind of visualize them is in the context of the NIST framework, which is looking at identifying threats, protecting against threats, detecting, and then automating and recovering from an event that's happened. You might notice that Security Hub shows up here twice. It's present in the identify stage because it has some components that look at configuration to help you identify potential areas of attack prior to that happening. It's in the detect phase because it's going to be collecting findings both from our services, including GuardDuty, as well as partner tools. And then, of course, Amazon is GuardDuty is our primary detective service that's on here. What's not on here because we just released it yesterday, but another service I want to make sure to mention is Amazon Detective. Amazon Detective, if you didn't notice, launched yesterday, and it will help you do the investigation on an event that comes through GuardDuty. So looking at kind of GuardDuty and its core functionality, when we decided to build GuardDuty a little over 2 years ago, GuardDuty launched pretty much 2 years to the day, right? So it launched at reInvent 2018. The whole purpose behind it was to build a threat detection service that could scale to our largest of customers, including ourselves. Right? And we needed something that could work at the largest AWS deployment as well as all the way down to the smallest one. And we also wanted to make sure that we understood that threat detection in Amazon is different than in traditional environments. It's not just looking at network packets or network behavior. We also need to protect the accounts. Right? So we wanted to do continuous monitoring of the activity and the behavior of your AWS accounts, including users, roles, as well as the resources that you're running. So it's not just looking at the network layer, but also looking at that API layer, because in a cloud environment, the API becomes an area, an attack vector, where someone might try to do something malicious. One of the other key tenets that we have, and we have this on all of our external security services now, is this concept of one-click activation. Right? One of the biggest challenges of security tools is making sure that they're deployed everywhere, that they're functional, that they're most up to date. Right? Anytime you have to install agents or put appliances into an environment, you invariably are going to cause friction with your application teams. You have the risk of performance impacts. You also have the challenge of making sure that it's there and that it's on. So one of our key requirements was no more than a single click or a single API to make the GuardDuty service active and providing value to a customer within a region. And similar to that, we also wanted to make sure that we covered all of our regions. So one of our core principles is our security services need to be available to customers wherever they run their workloads in AWS. And so when we launched GuardDuty, we launched in all commercial regions globally, and we continue to add support for GuardDuty as we launch new regions over the past couple of years. The types of threats that we wanted to detect was both known threats and unknown threats. Right? So we leverage threat intelligence to detect known bad actors, known bad behavior. And that's really kind of the base layer, right? These are the things that someone has already seen something bad from this IP or this domain. We know that this activity is bad, and so we can flag that. But we also wanted to be able to provide protection against unknown threats, using behavior and machine learning-based analysis to identify something that maybe no one's seen before, or could be user behavior that's possibly an insider threat, or someone acting in a way that's unusual. And then lastly, this concept of enterprise-wide consolidation and management. As we've grown at AWS over the years, the number of accounts that an average customer has also grown. Especially with something like AWS Organizations, makes it very, very easy to add new accounts. And because of that, we've seen the isolation boundary change in a lot of cases from using multiple VPCs within a single account to using accounts as an isolation boundary, which is a great security practice. However, it now means we might have hundreds or thousands in some cases of Amazon accounts. Trying to deploy and manage a security service across 1,000 different accounts is something that can be very, very difficult. So we wanted to make it so even our largest customers who might have several thousand accounts can get a consolidated enterprise-wide visibility into all the potential threats that are happening in those accounts into a single security master account. So when we launched 2 years ago, we had a concept called Master and Member. This allowed you to link accounts up to a security-owned account. So the owner of that individual account can see all of their findings, but importantly, your security team can see everyone's findings, and they can collect them all in that single place. Something that we're adding on to that we've kind of announced on Monday, was we were going to be adding support for AWS Organizations into GuardDuty directly to allow you to check a single box and say, I always want GuardDuty on in every account in my organization, and in this account should be the master for all of those accounts. And you won't have to do any bootstrapping or configuration to make that work. Every time organization vends you a new account, we will automatically, behind the scenes, enable GuardDuty, make their security account its master, and you don't have to do any additional configuration. So how we do this is by looking at 3 different data sources. So all of these data sources are essentially log-based. And one of the most important things to capture out of this is you don't have to turn these logs on. So most people obviously have CloudTrail enabled. If you don't, you really should. So CloudTrail is the API audit trail for every activity that's taking place in your account. However, VPC flow logs, a lot of customers don't always have enabled. They can be kind of voluminous. They create a lot of logs. And they have to be enabled on either an account or a VPC or an interface level. And so it can be difficult to make sure that they're always on. So we created and accessed those logs from a separate independent stream. So in order for GuardDuty to work, you do not have to turn on VPC flow logs. And also, of course, you don't have to pay for the VPC flow logs because we're getting them directly from the back end. When we analyze the flow logs, we get information about the network communication that the instances in your account are making. So if you're not familiar with flow logs, they're very similar to NetFlow, where you're looking at the IP that you're communicating with, the amount of data that was transferred, and also the directionality of that traffic. And this gives us information that allows us to identify if an instance is communicating with a known IP address that's on our threat intelligence list. But it's also what we use to feed some of the data models to identify unusual behavior for a particular instance. For example, looking at an instance that's suddenly transferring a large amount of data that's unusual for it. The one in the middle there, DNS logs, these are query logs using the internal VPC resolver in your VPC, so the .2 standard DNS that we provide. And so these logs we get from the Route 53 team. These are separate from the logs that you might get if you have a hosted domain, for example. And using this, we can then analyze all of the domains that your instances are querying and look at that and compare that against threat intelligence lists to identify potential malicious domains that are being accessed. And then we use the CloudTrail logs to identify activity to the API from potentially malicious IPs or malicious actors, but also That's how we profile and build machine learning models that understand what is normal activity for a particular user or role within your account, and to surface findings around behavioral activity that might not be malicious, but it's at least unusual and that someone might want to investigate. So how this all comes together, we have those 3 log sources, which again, we do all the heavy lifting for. You don't have to turn on. And they go through 2 separate detection engines. So we have our threat intelligence engine up there, which is really looking for, again, things that we can key off of based on those known threat intelligence lists. Some of the more common ones that we see in this particular instance, things like Bitcoin mining. Right? Unless you're a Bitcoin mining company, there's probably not a good, valid use case for having a Bitcoin miner on your EC2 instances. But also looking for activity or network connections to things like command and control servers, where there could be an implanted malware on the instance that's trying to phone home. We keep track of all of those command and control servers. Also things like Tor networks, and other malicious IPs. In addition to that, we do the anomaly detection. And again, this doesn't necessarily mean that something bad has happened. This just means that the activity is sufficiently unusual that it's created a finding. So looking for users that don't ordinarily change network settings, or looking for user activity against key API sets, the things that control IAM users or roles, for example. And then also unusual traffic patterns. So an instance that's communicating to an external IP address on a port that it does not normally communicate on. That could be an indication that there's a new piece of software on there that's doing something malicious. It also could be a change in the way your application is working, but it's unusual based on the previous model. It's important to note that for the machine learning ones, there is a learning period for these, so we have to gather the data. So it's best not to try to test them, because you'll tell us that'll get the tests into the data set. And then lastly, we deliver these as what we call findings. And we deliver them to 3 different locations simultaneously. So the very first one is Security Hub. If you have Security Hub turned on in your account, all of your GuardDuty findings will show up in Security Hub. You don't have to do any configuration to make that happen. It's just automatic. The second one is very new. We just launched direct S3 support a few weeks ago. And this allows us to write all of the findings directly to S3. We do it in a prefix format that's pretty much the same as how CloudTrail does it. So if you're familiar with how CloudTrail writes to S3, this should be very, very familiar too. And then the last one, which is probably the most commonly used one, is CloudWatch events. And we'll talk very deeply about how that works. That allows you to do remediation actions. This is how a lot of our partner tools integrate with GuardDuty to allow them to do additional visualizations or enrichments of these findings, or possibly send them to some sort of a SIM downstream. So how the threat intelligence part of this works. We get threat intelligence from 3 different potential sources. So out of the box, included with the service, we have partnered with both CrowdStrike and Proofpoint. So you don't have to configure that or buy a subscription for that. It's just part of GuardDuty. And that's where we get a lot of our good threat intelligence to apply to those traffic patterns. We also have a very large internal security team and a large research team on our side that generates a lot of our own very good threat intelligence. We have a fairly large viewprint of the network, so we generate a lot of threat intelligence off some of the activity that we're seeing going on the platform. And then the last one there is customer provided. So we have a lot of customers who might have access to proprietary threat intelligence, something that they've bought from another vendor. And we allow you to upload your own threat intelligence and add it to your GuardDuty detector. And we only use that for your account. So it's not applied to anyone else's, but it allows you to kind of bring your own threat intelligence that you can also apply. Some of the typical threats that we see being caught through threat intelligence, like I mentioned earlier, malware-infected hosts that are phoning home or downloading additional components of the malware. Anonymizing proxies, or things like Tor gateways as well, right? Trying to communicate outbound in a way that's trying to hide the activity that's going on within the communication. Sites and domains that are known to host malware, hacker tools, or otherwise used to deposit data as well. We also look for crypto mining pools. So crypto mining and mining pools is probably one of the more common thing that an adversary does if they find an application vulnerability and get access to an instance. A lot of times they'll use that to just drop a miner and try to monetize that activity. Similarly, on the unknown threat side, using that machine learning, right, we're trying to find signals and heuristics that tell us this activity looks suspicious, right? So trying to log in from 2 places within a time period that's geographically impossible, otherwise known as the Superman problem, or just logging in from a location that for that user they've never logged in from before. It's very unusual for them to do that, or accessing APIs in a way that looks unusual. So calling particular APIs they don't generally do, or having unusual failure rates. And these are all done through our machine learning classifiers to help surface that to someone on the security team to investigate, or at least surface to the user so they could determine whether or not that was actually them or that was actually normal behavior. In order to review these findings, we have a console, like most of our services. So you certainly can consume your findings in the console. As you can see there in that second to last column, there's 4 account numbers. And this is a master account, so it's collecting findings from all of these accounts. So again, if you configure this in the master member mode, all of the findings from all of your accounts will be visible in the console on the master account. Individual account owners can still go into GuardDuty and see their own findings as well. But from a security team or central security organization, this allows you to, again, see those all in a single spot. We also allow you to retrieve these through API. So every field that's in the console is in a JSON finding format, and you can call our API to retrieve them. However, the most common method is CloudWatch events. So if you're not familiar with CloudWatch events, it's a event bus essentially, and all of our security services, the ESS, will use CloudWatch events to emit findings. This allows us to push a notification versus having another tool pull. So we get near real-time notification when a finding happens, and we send it out CloudWatch events. We also do some additional aggregation when we do this. So one of the challenges sometimes with security tools is they can create a lot of kind of noise and having a signal-to-noise problem. And to help address that, we aggregate these events based on a lot of different keys and findings. So one example of that would be, if you leave an instance open to the internet on SSH, a lot of people will come and try to knock on that door. It's not a good practice to do that, but it happens. And there's no point in us sending you a security alert every few seconds if that keeps happening over and over and over again. So the first thing that we do is we aggregate all of that event. That's a like event. It doesn't matter if it's a different attacker or a different IP that's doing the brute force. The actual root cause here is a brute force attack. So we'll send you a single finding and let you know that's happening. We then let you configure how often you want to be notified if it's still occurring. So by default, we won't send you another alert for 6 hours, even if it keeps happening. You can change that to 1 hour or down to 15 minutes if you'd like. But again, the idea here is we don't want to send an endless stream of alerts down to the security team or the SOC to have to process. And all of these are in JSON. It allows you to store them somewhere, it allows you to take action on them. And how this generally works is you have CloudWatch events. You configure a CloudWatch event rule that matches GuardDuty findings. And then you take some action on it. So there's a lot of different targets that CloudWatch event supports. The most common one that we see is Lambda or step functions. And the reason for that is that makes it very easy for you to take that piece of data, that finding, and send it somewhere so it can be acted upon. As I mentioned, if you have Security Hub turned on your account, we will automatically also send the findings to Security Hub, where they will be aggregated and normalized in the common format, and they also get sent immediately out CloudWatch events as soon as they're received by Security Hub. And then you can take action on them from the Security Hub side as well, which is a good segue into the overview for Security Hub. So some of the key features and functionality, kind of the concepts behind Security Hub, as I showed you in the beginning, we have a lot of security services. Also, most of our customers have at least a handful of third-party tools they use as well. And it was getting to the point where there was too many places that customers had to go to log into, to view, or to aggregate, or to collect findings from. And we wanted to build a single pane of glass from a security perspective where all of your alerts, all of your findings can come into, and you can collect those from a single point, regardless of whether or not those findings are generated from one of our services or one of our partner tools. So we have 37 third-party partner tools that are present within Security Hub, and they all can send events directly to Security Hub in a common format. So one of the things that we created was what's called Amazon Security Finding Format. It's documented on our website, it's open to anyone, and it allows those vendors to take the finding that they would normally emit, translate it into our common format, and then send it to us for aggregation amongst all of the other findings that come from our services. We also took the same master member concept from GuardDuty and applied that into Security Hub as well. So now if you have all of your GuardDuty accounts in a master member, they will all show up also into Security Hub in the same format. The third and probably one of the most important and useful pieces of Security Hub, though, is the automated compliance and configuration checks. So again, as you start to get to large scale of accounts, it can be really, really difficult to understand and to visualize whether or not some developer has accidentally configured something in one of those accounts in a way that goes against a policy or a best practice. And so we wanted to have a consolidated view of how all of those different accounts are configured and map those against some compliance regimes. And then lastly, again, take action on those through the CloudWatch event bus. So we launched Security Hub GA at Reinforce earlier this year. And we have a single compliance pack in there right now. It's based off the CIS Foundation's benchmark for AWS, which is looking mostly at configuration choices and usage patterns at the account level. So it's not looking at your instances, it's more looking at how have you configured the account and does it follow some really good common best practices. There's 43 automated checks that are part of this. I'll point out it does require that you have AWS config enabled because we use the information from config in order to let us know when there's a change in that account. So again, it's near real time because we're getting that update from AWS config if there's a change to the posture of service within an account. However, the AWS config rules that are powered under this, you do not have to pay for. We manage those on your behalf. And again, best practice is to make sure we give you best practice information on how to mitigate or to remediate these findings as well. So just some of the top level examples of these. Making sure you're not using the root account, right? So generally speaking, you should never really use the root account unless it's some sort of an emergency. That should be a break glass account because it's all powerful and you don't have any attribution. CloudTrail, making sure you have CloudTrail turned on and that it's enabled in every region, right? These are very good common best practices. Making sure that you don't have security groups that are open to the internet on sensitive ports like SSH or remote desktop protocol. Identifying overly permissive IAM roles, right? Making sure that you don't use the administrative privilege. There's very, very few users or very few use cases where you absolutely always need to have the administrator policy. Right? And using least policy is a very good best practice. Helps mitigate any sort of blast radius if there was to be some loss of credentials. And then again, we give you the ability at the security master level to see how you're doing across all your accounts in a single dashboard. Identifying any of the accounts that are not compliant with one of those checks. And you can now drill down on that, look at the account, see why it failed that check. And then again, information about what you should do in order to mitigate or remediate that particular finding. In addition to the compliance checks, as I mentioned, we're aggregating these findings, not just from our services, but also from our partners. And we do that, again, through that master member, so you get that single dashboard, and it allows you to see all of the events, whether or not it's an endpoint tool like CrowdStrike, or it's a GuardDuty event, or an inspector vulnerability, any of the tools that report into Security Hub, you get all of those findings in one single central spot. But we do even one other step. So in addition to aggregating them, we need to then make them more useful to consume and help you identify the resources that are really at risk there. So if I tell you that you have a vulnerability on an instance and you have 100 of them, you're going to get 100 findings that tell you every one of those instances has the same vulnerability. That might not be the most useful way to tackle that information, right? So we created what we call insights in the product. And the insights help you identify where the real root cause here is. So in this particular example, we're showing the AMI. This is probably one of the most commonly used ones. And again, I don't want to know what instance I have to go patch, what image created that, because that's where I need to go fix that problem, so that way I don't launch new instances that have the same problem. We created 20 of these, and they're really built on filters against the findings. So we have a dashboard that has some of the top security findings that we've identified. You can modify that dashboard with your own. We have 20 pre-built insights that we created. But again, you can create your own. So any of the filters that you can create based on any of those findings from both us and our partners, you can create your own insights and have your own dashboard of what's most interesting to you. The other important part about this, again, similar to GuardDuty, is while the master sees everyone's, the individual account owner can see their own as well. And when it comes to compliance-related checks, pushing that down to the owner of the account is really important because it lets them know where they need to go and make changes to bring themselves into compliance while still giving your security and your compliance team the overarching visibility. So then that brings us again to what do we do with these? So now natively out of the box without doing any configuration, GuardDuty, Inspector, and Macy findings show up in the Security Hub. And like I mentioned, we have 37 of our third-party partners today. We have more that will be coming in the future that also support this common format and can send their findings into Security Hub and be part of the insights that you're able to create. And then those all go out CloudWatch events. And that's where you can then collect them, again, send them to a downstream SIM, send it to some, we have some partners that work specifically on what we call the take action step, which is to try to automate runbooks and remediation to do remediation against a particular finding or an event that's taken place. And so the next part of this I want to talk about is how do we take these findings and operationalize them in such a way that you can get the most value from them? So a security tool, especially a detective tool that generates alerts, you need to be able to do something with those alerts. Otherwise, they'll just pile up and nothing will get done. So in order to operationalize those, one of the first steps is making it so you have less findings. Right? You can't go and take action on or remediate against 500 or 1,000 findings a day. And so the most important part is to identify things that are normal for you, and let's filter those out. A lot of times people will call this noise, right? So there's noise coming out of the system. And when I look at noise, I look at it in 3 different categories. The first one is it could be a false positive, in which case, open a support case, and we'll certainly look to get that corrected. But those are fairly rare. The most common that we see is activity that's expected for that resource. So the finding that we fired was correct. The behavior was unusual, or it did something that matched a rule, but you kind of expected it for that resource. So an example, if you deploy a vulnerability assessment tool that does port scanning, we're going to create a port scan finding when it does that. Now, for this particular instance, you expect it to do that because that's its job. But you don't want other instances to do that. Or it could also be something that it's a threat that you're not going to act on. You've accepted that risk. For example, SSH to a Bastion host. Like I mentioned, if you open SSH to the internet, people will come along and try to brute force it. If you're not going to fix that, or if it's a Bastion and you're okay with it, it just creates additional noise downstream if we don't filter those out. But again, it's actually happening. But if you're not going to take action on it, then there's no reason to send an alert. So when I look at the foremost common types of either expected behavior or acceptable risks that generate a lot of noise for customers, the first one is instance credential exfiltration using on-premise source IP addresses. So one of our findings is looking for the use of instance credentials off AWS. So when you attach a role to an instance, it has the ability to access APIs and based on the policy that's attached to it. And we expect those APIs to come from the instance. However, if you're using something like Direct Connect or a VPN to route all of your internet traffic back on premise and go out your own gateway, then the source IP for that CloudTrail message will be your IP address and not ours. And so we will flag that as a potential credential exfiltration. But in this particular case, you expected that. You intentionally routed traffic that way. So we'll want to go and create a filter that identifies that specific source and suppresses it only in that case. And then this means if you get another one of those alerts after you've done that, that it's actually a real credential exfiltration. It's not just the ones that you get every day. It's a credential exfiltration that's coming from somewhere else. As I mentioned, port scanning or vulnerability assessment tools that might trigger things like brute force findings or port scan findings that are intentional, that's expected for that particular application. SSH brute force or port probes to intentionally expose services. So one of our findings looks for port scanners or other known malicious IPs that are probing your IP space looking for ports that are listening. If it's something you've intentionally opened to the world, like a web server, for example, there's not too much you can do about that, but you might not want to get a port probe notification against your web server because you've intentionally exposed that to the internet. If you get a port probe for a port that you don't expect, then that's different. And so the way that we handle this is through what we call auto archive rules. So auto archive rules are created as filters, and you create the set of conditions that you want us to suppress. And when we do this suppression, we still create the finding. It's still visible in the console, but we do not send it out the CloudWatch event bus. So it won't trigger any downstream action. It won't go into your SOC or your notification pipeline. It'll simply be visible in the console. And we do that so you can go and check the filters and make sure that the things that are being archived are the ones that you expect to be archived, and you're not accidentally suppressing something that you don't want. One key point to call out is only the master account can do this. Right? We didn't want it to allow individual account owners to create their own suppression rules because they're generally not the security team and they have a security master. And so we wanted to leave that capability in the hands only of the master account, but also it applies to all of your accounts, which is, again, helping that enterprise-wide manageability so you don't have to go and create those suppression filters on 100 different accounts. You can do it one time at the master, applies everywhere, and then we will start suppressing the events that match any of those filters. The way that you do this in the console today is by creating a filter. So when you create a filter, it's going to only show you the events that match the chips that you have on the filter bar. So for this example, I'm looking at that instance credential exfiltration from an on-premise gateway. There's two ways that you can identify your on-premise gateway. So if you're a larger customer, you might have your own autonomous system number, or ASN. And if you do, you can then match based on your ASN number or your ASN organization name. So you put in your ASN number and the finding type of instance credential exfiltration. That will highlight and bring to the fore only those findings that came from your on-prem gateway that were of that type. Then on the far right-hand side, there's a button in the filter bar that says Save and Edit. And when you click on that, you will get a little box drop down that allows you to create a name for that filter, give it a description, and then there's a box that says Auto Archive findings that match this filter. So when you check that box, this becomes not just a regular filter, it becomes an auto archive rule that allows us to suppress those findings. That's an example for CloudTrail type findings. So for that SSH brute force against a bastion, you can use any of the keys within the finding that are on the filter bar to identify these auto archive rules. So in this example, we're going to use tags. And I might do this because what if I have a bastion host in all of my accounts? I don't want to put in 100 different IP addresses or instance IDs. I can just have a common tag. In this case, I've called it Linux Bastion. And that will apply against all my accounts. If the finding type is SSH brute force, it has a tag with key name and a value of Linux Bastion, we're going to go ahead and suppress those brute force findings. You can also do this through API or CloudFormation. So through CloudFormation, you can create your filters. In this case, we're looking for the Qualys one, in this case for port scans. And in this case, I've matched off the instance role. So that's another way, right? In case I might not know what instance or AMI is going to create these in all of my accounts. So, but I know that I might attach the same instance profile to all of these particular instances. And I'm going to create a filter based on that for the port scans. and auto-archive those as well. So the distinction when you create a filter in CloudFormation is the action is no op if it's a filter, and it's archive if it's an auto-archive rule. You can also do this through API by passing a JSON payload. Very similar, this is the same example, but again, just giving you an idea that there's multiple ways you can do it. CloudFormation is nice because it allows you to check in those filters as code, so then you can track which of your auto-archive or suppression rules are active and see when they were changed over time as well. So once you've gone and removed a lot of the things that might cause unnecessary noise, the next step is to figure out how you're going to take action on the next findings that come in. When we launched GuardDuty, we had about 28 findings. We now have over 56. So we've more than doubled the number of findings. So one of the things I try to tell people to do is don't try to boil the ocean and operationalize every single one of those finding types, because you'll never be done. Because while you're doing that, we're going to add more findings, and then you'll never get to a spot where you've figured out how to handle them all. So what we see work really well is start with a small, manageable number of high fidelity, high severity findings, and action on those first. And then once you've built out and defined a playbook and some automation for that particular set of findings, move on to the next set, and then just kind of keep going in that fashion. Normally, when you do this, you're going to want to start by understanding what steps you're going to take and build out a playbook that you can do play by play, what actions you want to do in response to a particular finding. Ultimately, you want to automate this as much as possible, right? And as much of these playbooks as you can put in code, the easier your life will be, but also the more repeatable it will be. So one of the questions I've gotten often from many customers is, that's great, where do we start? What are the findings that are most important that we should probably operationalize first? So this is my personal list of 7 findings that I think are probably the most easy to automate and to take action on, and are probably the most high severity ones. So that first one is, like I said, instance credential exfiltration. Someone has taken credentials that were meant to be used by an application that lives on an instance and used elsewhere. This could be an indication that the instance has had an application compromise and someone's been able to extract those credentials. And now, because we've filtered out all of the use cases previously where that's expected, if we see that finding, this is probably a real security event. The second one on there is IAM user Tor IP caller. What this means is somebody has used your API credentials, and they've done so from a Tor gateway, which there's really no legitimate use case for calling our APIs through Tor, because the only reason you're doing that is to anonymize the source of that particular action. The next 2 are both Bitcoin-related findings. The only difference between them is what data feed we use to detect that activity. So the one that ends in DNS was from a DNS query, and the one with .b means it was from an IP-based, so using the flow logs. And again, we see a lot of times the action that adversaries take when they compromise an instance is to add it to a Bitcoin mining farm to monetize your compute. So those can be a good indicator that you might have a compromised instance. The one below that is a port probe for EMR. So we have a regular port probe that will look at a large number of ports. Again, if you leave things open to the internet, someone will come probe them. This one in particular, though, is a much higher severity, because this means you have an EMR master node on the internet with a public IP and a security group that's allowing access to the YARN port. So the YARN management port on EMR doesn't have any authentication, which means an attacker can come by next and try to exploit that. So if you get one of those, that means something you definitely want to address that security group role. And then the last 2 are also related to Tor. So in this case, it's Tor client and Tor relay. And the difference between the 2 is the Tor client means someone is running Tor on an instance and they're communicating outbound. And again, especially in an Amazon server environment, there's not a lot of good, valid business cases for egressing out to Tor from an instance, right? Other than to try to exfiltrate data or to do something malicious. And then the last one means you're actually running a Tor exit node on your instance, which again, unless you're in the business of running Tor exit nodes, is probably not something you intended to do, and that means other people are actually routing traffic through your instance out to the internet. So how do we enable the automation? Once we understand, we've filtered out the noise, we know where we want to start our focus, there's some key steps to understanding how you enable automation for these events. The first one is probably one of the most important ones, is to understand that it's not one size fits all, right? You need to pick the right action based on the affected resource and the type of finding. Some resources, you're never really going to get past notify or ticket, right? You also might want to isolate some resources. Some you might want to terminate and replace. So for example, if you have a completely stateless application and it's deployed using auto-scaling and it's sitting behind a load balancer, you might be totally fine with just removing that from the load balancer, terminating the instance, and letting auto-scaling simply replace it, so as long as you have enough existing capacity to handle your load. However, if it's a relational database that you're running, that would probably not be an appropriate action, right? So you need to understand what is the right choice for different findings, but also for the different resources. Which leads to the second bullet, which is absolutely job zero, is you need to have a well-defined and consistently enforced tagging strategy. Because we're going to use automation in a lot of these cases, there's going to be code that's running and interpreting the finding that comes from the security tool. If the code can't figure out whether or not that's a stateless web application or a database, then you can't effectively make a choice. And really the best way to understand that or to express that is through tags. And again, since we're going to try to do this in an automated fashion, you need to have those tags everywhere, and you need to enforce that to make sure that the automation can actually be effective. Now, when we try to go and get tags enforced everywhere, that means that the security team is going to have to express to the application owners what tags they need, what data is required in order to enable these activities, which means we have to start working more closely with our application owners, which hopefully we're already doing anyways. And then lastly, also when you get going, don't start with terminate or isolate, right? We want to start with notifications. That allows you to see and test the response of the automation, so you know what the action would have been. Once you're comfortable with that, then you can start moving to more assertive actions, like perhaps isolating to allow further investigation or termination and replacement. So let's walk through a couple examples of how this looks in practice. So again, this is our finding pipeline where we have some findings coming from GuardDuty, could also be coming from Security Hub. CloudWatch Events is matching a rule, sending it to a Lambda function. Important to note, you don't have to do just one thing. We could send it out to our partner tools, as well as try to do some sort of automated response at the same time. So the first example we'll look at is incident response using network ACLs and AWS WAF rules. So this one's a little bit more of a complex example, and in this case we're using step functions to call multiple Lambda functions. And the idea here is we had a finding for either command and control or an inbound brute force from an IP address, and we want to block access for that particular adversary. And so when the finding comes in, it will show the step function, and the first thing it's going to do is update your AWS WAF with an IP block list. That will say, I want you to start rejecting connections from this particular IP. And you can also then push that to a separate Lambda function that will send it to a network ACL. So if you're behind an AWS WAF, putting it on an IP block list there is great, but for other applications, you might want to also prevent connectivity to those IPs using the network ACLs. When it does this, it creates also a Dynamo table that stores time to live and will automatically clean those rules out over time. So then going forward, if someone that matches any of those block lists tries to communicate, it'll of course be blocked either by the WAF or the network ACL. This particular example, we have a security blog for, including CloudFormation and all of this Lambda code. So if you go to the AWS security blog, we have posted a few months back this particular example, like I said, including a CloudFormation and the Lambda code that enables all of this. Another very interesting use case and another tool that's really powerful for helping you respond to security events is Systems Manager. So Systems Manager, if you're not familiar, is an agent solution that runs on it's embedded in all of the AMIs that we have. And it allows you to do a lot of different activities, such as run commands on hosts, or collect logs off hosts, get software inventory. It has a whole host of different functions. But in this case, I might want to collect some additional telemetry or information from an instance in response to a finding. And that's really important because if you think back to the log sources that we're using for GuardDuty, we're using flow logs, DNS, CloudTrail. We don't have any on-box telemetry to tell us what processes are running or what log information, who's logged into that particular box recently, right? And we can use Systems Manager to execute a run command to collect information off that host in response to a GuardDuty finding. So if we tell you the instance is communicating on an unusual port, you might want to have Systems Manager collect the last people who've logged in, what processes are running, maybe start collecting packet captures, do memory capture with something like Lime. You can also use API calls to create a forensic snapshot of the EBS volume before you do any of this. So you have a point in time of what EBS looked like, and then you can also go and start collecting all of the information off that host, which now when your incident responder goes to look at it, they have both what came from GuardDuty as well as some host level telemetry to give them more insight into what was really going on in that particular event. So kind of the last one, and just going through, one other thing to call out is when you do this, you don't only have to do one thing, right? So you might also want to consider, from a stateless standpoint, that idea of a completely stateless web app, I want to terminate and replace. You also probably want to first remove it from its load balancer. If that instance has an IAM role and you believe it's compromised, you definitely want to remove the role from that instance. So you can do that now by removing the instance profile to essentially remove those credentials in case it is actually compromised, they can't be used anymore. Snapshotting the volume, again, so you get that point in time. What did the root EBS volume look like when this event occurred? And then to do isolation, you would want to replace the security groups on the ENI. So you don't want to modify the existing security groups, because that could affect other instances, but rather you'll want to remove the current security groups and replace them with a very restrictive one that only allows access from an incident response network. And then it can, of course, attach a forensic ENI so you can connect to it. And then when you're done, you can go ahead and terminate that instance. All right, I think we have some time for questions if there are any. We have some microphones around the room. If you have any questions, happy to take those as well.